about testing and testing strategy into microservice architecture. It's written from experience from campaign group and testing and deployment automation team. A few words about us. So I'm Benjamin. I've been working at Criteo for 5 years now and 13 years as a C# web developer. I am a lead of one team in the campaign group in expansion integration, previously product engineering. And regarding tests, I'm an advocate for sociable tests, property-based testing. That's something we'll see later on in the presentation. And I used to be in the past, used to think that TDD was not for me, but someone in my team changed my mind. So you can also change your mind about testing. Arnaud?
Yes, hello, I'm Arnaud. I'm at Criteo since 2 years. I'm an ex-member of the team Testing is Doubting, and I'm a BDD lover thanks to my experience. And I recently joined Tada team, and I was previously in the campaign core and budget team for almost 2 years.
And this presentation is sponsored by Chartreuse. We are both based in Grenoble, which is the green capital in European Green Capital in 2022. The agenda, we will first take a look at the principle behind testing. Then we will take a look at the tools Criteo provide and what we use to test systems and applications in service architecture. And if we have time, we will take a look at some advanced testing patterns. Without further ado, looking at the principles behind testing. So, triple W. Why, where, and what. Why am I writing a test? Where or when should my test be run? And what should I test? These are the 3 questions you should ask yourself when you are either writing a test or thinking about your test strategy. We will focus on the first one, the why, which is really important, because if you are able to answer why you are writing a test, the 2 others, where, what, how it's done, will be much easier. It's not only I who is saying this. Simon Sinek, a technical writer, wrote a book about it, and this book is named Start with Why. I will spend some time on this slide, which is really important in my opinion. From experience, most of us, we know how to write good code. And most of us do not know how to write good tests. Most often, it's because we don't know why we are testing. It's not personal. If you look back at your experience, whether it is in engineering school, boot camps, in your work experience, what you read in blog posts, in books, in conferences, most often it's about code. It's about system design patterns, how to write better code, but you don't learn a lot about testing and testing strategy. Usually, the only or the most common knowledge we have all together as developer is that code should be tested. We shouldn't deliver code to production without it being tested. But how to write good tests, what is a good test, is much more open to debate. If you tend to disagree or you're not 100% convinced by this, I want to ask you one question. In your last or latest code reviews that you did you had the same quality expectations for the application code as for the test? Did you check that the tests were readable, meaningful, that they were testing the right thing with the right scope and so on? Or did you just check that they were tests and they were green? Usually the answer is more the first one, because we focus on the code and test. Yeah, it's just a tool that ensures that the code is working. Looking at how we could write good test and what is a good test. 3 things for a good test. A good test is defining what your app should do. This is one thing that stems from TDD, so test-driven development, also named test first. It's a software methodology which states that you should first define what your app should do, and you do it using a test. Only then you are writing code, and this code you end writing code once your tests are green. Two things that are enforced by design by TDD is that your app is doing the right thing because you defined it at first, and second thing is that you don't have additional extra code that is unnecessary as per the requirement. That's one thing to make a good test. The second thing is that a good test should give you confidence in what your code is really doing. It's good to define what your app should do, but if you are not sure that your code is doing what you define, you will have issues. Last thing, good test should explain future developer, could be you in 2 months or even in 3 weeks, what the code does. So it acts as documentation once a feature is released in production. That's the 3 thing for good test. Defining what your app should do gives you confidence in what the code is really doing and explain the feature to future developer. This leads us to our first key takeaway of this presentation, is that the test should be descriptive and readable. If you have descriptive and readable test, you will be able to easily define what the app should do and explain what it does. Pro tip, there are most often questions within teams about should we duplicate things in test or not. When we are writing code, production code, we tend to be dry. Don't repeat yourself. No duplication, but also less descriptive. The good practice for test is to be more dump, to write descriptive and meaningful phrases. It's okay to duplicate if it makes the code more readable and descriptive. So we saw good test. Now let's dive into bad and ugly test. There are 2 common smells about bad test. The first one is widely known. It's about under-testing. If you don't test enough, your application is exposed to regression when change occurs later in the development phase, but it's also exposed to bug in production at your first release because you are not always verifying that your app should do the right thing. That's widely known. The second one is much more pernicious. It's overcoverage. If you test too much, and if you test too much, at best, it's counterproductive because you are adding tests which are adding little value. And at worst, this is nullifying attempt to change the code later on. It is making refactoring harder. Let's look at an example. When you are writing tests, you cement your application. If a change will need to break the cement, the test will be red. You should do it for feature, for what your application is meant to do. If you test too much, you are adding unnecessary constraints. You are making your wall with too much cement. Such bad smell could be testing code internals. Whenever you think about testing a private method, this smell of over-testing. Whenever you want to test a non-use case, example for this, you have a feature, a unit you want to test, and entry point of this unit, we are checking that part of the argument is non-null. Okay, it's not null. You have a method inside your unit which is taking this argument, and while coding, say, okay, what to do with null value? Okay, I will throw a custom exception, and you do it. Should you test it? Is it an implementation choice, or is it a requirement? This, in fact, is a non-use case. If your method is internal to your unit and not shared outside of your unit, you don't have to test this. it's a non-use case. And if you do it at one point, maybe 2 months later, someone will find this method and say, okay, this one is really useful. I need to use it in my unit, and I will make it a shared method. And they will wonder if this custom exception is a feature or an implementation choice. If you have a test for this, most probably they will think it's a feature and they will continue to support it. Good choice to do to prevent overcoverage is to think twice before making a method public. Above all, in the .NET and C# development community, we tend to make lots and lots of methods public, which is not a good practice. And even for classes, if you have a private class to another class, just keep it as a subclass. It's fine, and it will be tested with a bigger unit. That's better than cementing everything together. And the last thing, you should think before you write a test. You should think feature. You should not think about the code, about the implementation, but more about the feature you are testing. This leads me to the second and third takeaways. You should not test everything that is testable. It's counterproductive. And you should test feature, not code. Now, moving to Criteo's testing stack. What are the tools that Criteo's and testing and deployment automation is providing to developers to test their application and systems? We are in a service architecture or microservice architecture, depending on where you put the cursor. We have several scopes. From the smallest one, a unit, which is part of an application, a small piece of code. We have an application, usually here, which is usually making requests to a database. You can test everything together in isolation, your application plus your database. Most often, your application have those HTTP requests to dependencies. So you want to be sure that what your dependency do is what you expect in your application using contract test. And you have more end-to-end tests like functional health check or manual test, end-to-end test. Let's start with the smallest one, the unit test. Unit test, it's usually quite known. You are testing a small unit of your application. It should be run fast, and we should have lots and lots of unit tests. The good practice for unit test is to have 3 sections: arrange, act, and asset. So the 3A pattern, you can rewrite them using given, when, then. It's exactly the same. We try to put as little as possible in the arrange. Usually the important part of the test is more in the assertions. One pro tip is to use fluent assertion. So instead of using the basic and unit, assert that 2, is equal category elements.count, something like this. We can have fluent assertion in close to real English sentences, and it's much easier to read than usual assertion. If you look at the second one, it's clearly obvious. The code says is read as check that category bid-amounts contains only elements that match this predicate. It's much easier to read and to understand what it does, rather than, okay, I want to check that this list dot all verifies this predicate, but all, what does all do when there is no predicate? I don't know. This is much easier to read. An example of a well-written test case here. So we are in a test class, should not be archived, rule should, or system under test is a rule, should not be archived. And if we read together this test, so this test is named should return error when ad set is archived. Okay, we are creating an ad set with an asset test model builder, archive, build. So we have an archive asset. We are building an asset validation context with the asset we just created. We are calling the check method on the system under test, and we are checking that result is success is false, and checking that result error ID is equal to asset issue ID, asset is archived. Reading the test gives you everything you need to understand what the test is doing, why it's there, and what the feature should do. That's really important when building a good unit test. So that's it for unit tests. Pretty simple, right? In fact, there is a big challenge with unit tests, and we already talked a bit about it. It's with over testing, over coverage. Cyril Dupuy-Dobie, who has been a software engineer for more than 30 years and an active member of the Craftsman community, he wrote that you write a new test when you need to fulfill a requirement. You do not write a test when you need to code a new class or a new method. If you do it, it will lead your code base to excessive coupling between test and implementation details. Your test will break whenever refactoring occurs. This is gold. If you test too much and if you test the implementation, you will cement everything, and any refactoring that could occur afterwards will be hell. If we look back at the funny picture on the left with a QA engineer, a quality assurance engineer walking into a bar, this is a funny image. But if you look at this picture, what it describes is not implementation detail. It's a feature. It's a feature about ordering drinks, beers into a bar. It's if the order is a command, if it relies on a repository, a database, message, it does not care. It's testing the feature. And that's the danger of unit tests. Unit tests are so easy to write that usually we are going autopilot. There is one class in our production code. Okay, we will create one test class. There is one method. Okay, we will create several tests for this specific method, and we will mock every properties. This may work, but if you have too many layers in your application, technical layers in your application design, if you do this, you will have one unit per layer, and everything will be abstracted with mocks. And all your technical layers will be units, and they will be cemented with tests. Which means if you have a technical refactoring, every test or most of the tests will break. And that's a mess, because when you are doing refactoring, you want the test to support your refactoring and say, okay, you didn't break anything, rather than 100 of tests to become red because you change one command for a service. So all in all, unit tests are easy to write, but it's difficult to write them well. And the good thing to do is to identify, to think about the system you want to test. Is it a system about a feature? Is it, or are you more thinking about technical layers? Fourth takeaway, do not go autopilot. You should think about your system, the system you want to test. You should think about the unit of your unit test. And now it's Arnaud's time for the test in isolation.
Yes, looking at our application now a bit wider, the test in isolation, for those who doesn't know what it is, it's running your application isolated from the rest of the stack except the DB, which is run locally on your machine or on the Jenkins machine. Next slide, please. It allows you to basically run your application and a local DB, and it's really easy to debug. You can even connect to your local DB with a basic Azure Data Studio software or any software able to connect to a SQL Server database. It's a bit slower than unit test, so still when you are writing tests, you have to put that in the balance. If you write a ton of tests, it's not. It will be a bit slower initially in the setup. Locally, you can set the reuse local DB variable to true. It will helps the for your local debug to run faster. Your local DB will remain in memory. It's a very powerful tool that helps you also to create test data for your testing part with the test data creator. And it's also a nice way to test store procedure. If you have a business logic into your store procedure, you can test it by this way. And it's a very powerful tool, which is available for C#. Not familiar with Java Stack, but for C#, you have a framework on top of it, which makes the stuff really easy to use and a very powerful tool, definitely. Looking again a bit wider, your application will be talking with other application, other dependency. And if you want to cover the compatibility between, yeah, it's not working on Mac, but it's a problem of Windows. If you want to ensure that your application is working with other application, that's where contract testing came into the game. Next slide, please. So for those who are not familiar with that, there is an initiative at Criteo, I think it was before I joined, to implement contract test. Contract testing approach is to define a contract which is between a consumer and a provider. And this contract will, from the customer side, being a provider mock on which you can base your test. And from the provider side, it will be a contract verifier, meaning that every request that the consumer is sending should have this kind of response. For example, for an API, you say, okay, when I give you this URL with this parameter, I expect to have a 200 response with a structure like that. Part of this stuff is already covered by auto-generated clients in the Moab. So what has been implemented is a different approach, which helps you to define more functional tests against consumer and provider. Next slide, please. At Criteo, contract testing, like I say, are a bit different. It's consumer-driven contract testing, but the tests are written in the provider repository. And during the build, the contract tests are run against the real implementation, but also the fake. It ensures you that your fake is behaving the same as your real implementation, but it has the drawback that the fake implementation you rely on must be at least behaving for your test like the real implementation. So it's costly to implement in the end. We receive feedback coming from team using it. That's it's a bit of pain to use. Regarding that, in Q1, we may improve the contract testing part based on feedback we receive. And so maybe we will change the implementation of it. One of the advantages of the contract, the key point of contract testing is that you can run your contract test versus prod, meaning if you are releasing the application A on the version 100, and in production you have a repository B on version 80, we can ensure that the contract defined will be compatible, and so your application A will be working with the Moab 100, will be compatible with the application B on the Moab 80. So that's the key points. But it's not very how to say, used for now. We have only a few jobs doing that. Okay, on the front-end testing part, it's a bit more wide. At Criteo, we were supposed to have a testing permit. At Criteo, generally speaking, we are supposed to have a lot of unit tests, a bit of integration test, and less end-to-end test. But for front-end testing, what we usually do is put Cypress everywhere. So, next slide. We use Cypress for, just quick introduction. Maybe some of you doesn't know what Cypress is. Cypress is a JavaScript end-to-end testing framework, replacing basically Selenium in the industry. It runs tests in a browser, can run actually on multiple browsers like Firefox, Chrome, and so on. In a very simple and descriptive way. On the right side, you can see an example of Cypress test. Is really easy to write, really easy to understand, and it manipulates the application through a browser. So it's like your user should do. And it's supposed to be fast and reliable. And from my experiences, it's not fast and it's not reliable. Or at least it's flaky and it's a bit slow. So at Criteo, we use it for backendless tests. Next slide, please. For backendless tests, so the concept of backendless test is just your front-end application is running against static mocks for your test, which replace your backend. So it's quite fast, but it's a bit costly to maintain, because each time your API will be moving, you will have a cost to update your mock. And also on front-end versus backend in isolation, which are tests run at post-mob step. And on this, the setup is a bit more complicated, but your application will be running with your backend for front-end isolated from the rest of Criteo. So that the two use cases we use Cypress, it's very common on campaign group to use that tool. Next slide, please. I will not enter into the other test detail, but just for you to know, we have also functional check, which are sanity checks run after deployment, just to ensure that your application is running. Performance tests also, I don't think we used it in campaign, but some teams use it with Gatling. Traffic replay, especially for RTB and arbitrage. There is an application called France Replay. It's not a joke, it's a real application, which replay traffic to test that the RTB and arbitrage are working correctly. And more recently, API Developer Experience released a new Kata, which is which is for testing your API using Postmat collection into your pipeline. So that's all the test tool we have. If you have to take something from that, the tools are just tools. It will depend of the use case you want, and knowing all the possibility you have, put the effort at the right place to maximize the coverage, or at least avoid regression in your code. Then we will speak about advanced testing pattern. And the first one I want to present you is BDD, my love. BDD stands for Behavior-Driven Development. We used it in campaign core and budget team with SpecFlow for C#. And it's basically a descriptive language. No, descriptive language is an approach that's to write your test with sentences understandable by everybody, basically. On the left, it's a real test case in your code base, in our code base for testing assets and behavior, and it improves readability. It is maintenance, because behind every step, so behind every line, you have codes which will set up stuff or doing assertion, and you can reuse your step in any test you want. And it's also a very powerful language to discuss with the product. We had a very good experience with one of our PM for budget migration, which was written his expectation on BDD standard with the given when then structure, and we implement the scenarios he asked for, and it was very easy to discuss and adjust the test or adjust the specification based on that language. So I really enjoy it. I'm a bit surprised that not everybody use it, but it can be used, like I say, for C#. It exists also for Angular. For every application, you can use this pattern. And it's very powerful and very helpful in the end to make good tests.
To be fair on this topic, it was used when we were in .NET in Windows, and SpecFlow was used for this. And when some application moved to .NET Core, SpecFlow.NET Core was not yet available. That's one reason why it has been dropped. But we have no reason now not to use it again. For the next advanced testing pattern, I want to talk about system under test builder. So we said earlier that our test should be descriptive. We should put as less as possible code into the arrange part of unit test. And the system under test builder is a way to decouple the way you build your unit, your system under test, and the test code. If we look, and again, if we read the code on the left, we have a test which should validate ad set are eligible when resetting category bid amounts. Okay. And our system under test is a category bid amount reset command with an archived ad set, an incompatible ad set, an invalid null budget, null bid amount ad set with IDs that are provided here. We are executing the command, and afterwards we are checking asserting. It's not using real fluent assertion, but you can see the pattern here. The system under test builder is really easy to read. You don't care if it's using mocks, if it's using the real implementation. You don't care how an archived ad set is modeled, if it's a status or the delivery status or the weight. I don't know. Reading the ad set, I just know that it's archived. It enables your test to be descriptive if your feature does not change, but the technical implementation change. For example, the category bid amount reset command has a new parameter when you need to create it in your constructor. This won't change this test code, and it shouldn't, because the feature does not change. What will change is the system under test builder. It can be shared and reused across tests. It will still be readable. And one nice advantage of system under test builder is that when you create a system under test builder, you will think about the system you will test. So it kind of ensures that at least you wonder if it's the right system that I am testing, or if I need to go a bit wider. Speaking of system under test, I want to stress a little bit about solitary and sociable unit test. Looking at the left side of the screen, we have Java code for once. We have a product service, which is able to get a price for a product and is using a pricing engine. The pricing engine can calculate a price for a cost given a markup. If you test it the solitary way, what you test it, I mean, testing the product service, what you will do is, okay, I need to build a product service. For this, I need a pricing engine. What I will do is mocking it. So you create a mock of a pricing engine, and you say, okay, when I am calling the calculate price method with argument 10, then it should return 13. You build your product service, you call it, and you assert that the result is the one that your mock has returned, and you verify that you call the mock. If you test it the sociable way, your system under test will use the real implementation of the pricing engine. You will have a wider scope, and your system under test here is easier to build. You just build a product service with a new pricing engine. And your assertion is that your feature is working as expected. We are not verifying calls to mocks. This is a bit easier to read. There are pros and cons for both ways to do. The thing is, with sociable tests, you are it's much less brittle. Let's say you have the feature change, and now depending on the consumer can have fidelity cards, and they can have discount. So you will have a consumer to a new argument, input argument for your get price method, which is a consumer. With the first approach, the solitary one, you will need to change your mock, you will need to change your verify, and you are changing your test assertion, and you are in the end testing mocks. With a sociable unit test approach, you will create a consumer and you will pass it to your get price for method, and that's it. Your feature does not change. Property-based testing. This one is my favorite. On the right side, you have a picture of the 5th floor with Nicolas Dubien. Nicolas Dubien is used to be a Criteo in the past, and he's a maintainer of FactCheck, which is a TypeScript library to do property-based testing in TypeScript. What we do when we are doing testing isolation or unit testing usually is what we call example-based test. So we are given, we define input for a system, and we expect output to be the one we expect. With property-based testing, what we do is we ensure that properties of the system is verified, whatever the input. Looking at the first code here, the first example, it's a rule, a property about a name should be valid, and we need a non-empty string as an input. It is not defined, it's a property. We create an add set, assign the name, create a validation context, call the check method, and we assert that it's a success. Never once did I specify what is the value of a name. This is a property-based testing engine duty to find of value, to determine this value. And it will for sure test with AAA or my awesome add set name, but it will also think about testing with Chinese characters, emojis, very long string, something we never did when we do example-based testing. Another case where this kind of test really shines is when you have mappers. So example-based test for mappers is a pain. So you have a class, you convert it to another class, and you check that field by field, everything is what you expect. You can do it, it's fine, but it's really cumbersome. And if you have any branching ifs in your converter, your test will be a mess. With property-based testing, it's pretty easy. One property is, okay, I'm mapping from class A to B, and I'm mapping back from class B to A, and I should have the same value before and after the back-to-back mapping. This is what is done in the second example. We have 3 integers as input. We are building a key, a valid key as a string. We are converting it to a C# model and back to a string, and it should be the same string. And that's it. I don't have to test with very big integer, max value, min value, 0, -1. I don't care. It's the duty of the engine. From my experience, it's really useful for mappers, converters. It's useful to replace test cases where you have simple tests. If you have test cases, usually you are able to describe what should be within the test case. And you should be using property-based testing instead of examples. Most often, properties are hard to find. That's a deal. You can have more information on Confluence. The PowerPoint will be available after, I think, tomorrow. We'll see later. Last one, mutation testing. This one was investigated by Guillaume Poncier in campaign teams, and the investigation was pushed further by Iman when doing internship in TADA. Mutation testing is about testing your test quality. You want test, that's good, you are fine with it, but is your test really catching regression? And that's what mutation testing is about. Mutation testing will take your original code, not the test code, but your code, production code, and it will make some changes, adjustment. It will change lower than to a greater than. It will remove some blocks inside the if. It will change an initializer from a non-empty list to an empty list. It will try lots of variants tries lots of mutations, and it will ensure that your test suite is catching this regression, because it is a change, it is a regression, it should be caught by your test. That's what mutation testing is about. That's all for the advanced testing methods. If we want to wrap up what you should take away with you out of this meeting, first one, your test should be descriptive and readable. Dump over dry for test. You shouldn't test everything that is testable. You should test features, not the code. You should test the requirement, not the implementation. You should think about your system under test. Don't go autopilot. You should use appropriate tools. We have several tools. Some tests could be unit tests, could be more unit tests with sociable units, a bit bigger unit tests, could be test in isolation, could be functional tests. Think about the tools and choose the appropriate one. BDD is really, really nice. Arnaud is saying that BDD is life. Maybe not, but quite close. And last thing, test is code. We learn how to code better, and we are improving the way we are coding not every day, but we are improving with time. With test, we can do the same thing. There are methodologies, there are literature, there is some presentation. It's just harder to find, but we can make progress on it. And trust me, this will make you a better programmer if you learn to test better. That's it. Thanks a lot for your attending.